my dear students, I will go to another topics from stereoisomerism, that is D and L nomenclature. Don't confuse with this D and L. This is nothing but a capital letter D and capital letter L. This has nothing to do with the small letter D and L. No relation. They have no relation. I would like to state in the beginning that small letter D and L, capital letter D and L have no relation. Okay, anyway, what is this? It is the nomenclature. It is the nomenclature uh, used primarily in carbohydrates uh, carbohydrates and amino acids. It's used in similar compounds also. Okay. uh, these carbohydrates hydrates and amino acids, these carbohydrates and uh, amino acids are optically active active. They are optically active also. Okay. What is a carbohydrate? Carbohydrate, you will learn it in detail. Carbohydrate, it is a polyhydroxy. It is a polyhydroxy optically active optically active aldehyde or ketones. Optically active aldehydes or ketones. They are polyhydroxy optically active aldehyde or ketones. Okay, fine. Let us go in details of these isomers. Well, this nomenclature. D, capital letter D, when second last OH or NH2 groups are oriented into right direction. Okay, that is T. Let us take some example. Suppose you have a molecule like this, CH2OH, CHO, HOH. According to the Fisher projection, this cross point is chiral center. Cross point is the chiral center. Now, second last, that is nothing but this one. This is the second last OH group on right side. Therefore, this is T. This is glyceraldehyde. D-glyceraldehyde. Okay. Now, it has another option, that is CHO, CH2OH, but HOH, this is L-glyceraldehyde. Okay, now suppose you have glucose also, or many compounds, CHO, OHH, HOH, OHH, H. Imagine if I write OH here and CH2OH, what is important? This is a second last, therefore this is D-glucose. D glucose. Okay. Now suppose you have another options like CHO, OHH, HOH, OHH, CH2OH, H. But the second last OH group on left side, therefore this is L glucose. Fine. This is nothing but a L glucose. Now in the case of amino acids also this is possible. Suppose you have an amino acid COOH, CH3, NH2H. This is D amino acid, D alanine, it's nothing but D alanine. Now L, if it is L reverse order, COH, CH3, H, NH2. This is a second last. Okay. Therefore, this is what is about D and L. Therefore, what is L? Now I am going to write the L. What is L? Now we know that. What is L? L is nothing but when second last L, when second last OH or NH2 groups oriented into left direction, then it is called a L. Left direction, that is called a L. Okay, that's very simple, very simple. Normally this is applicable to amino acids, carbohydrates, like that compounds. Okay, I think this is okay for you. We know that all natural carbohydrates are D, all naturally occurring amino acids are L. You learned it. All naturally occurring amino acids are L, all naturally occurring carbohydrates are D. Now another one is Erythreo Thereo Isomer. Erythreo and Thereo Isomer. Erythreo and Thereo Isomer. Erythreo and Thereo Isomer. Compound shows this type of compound show this type of isomerism if they satisfy following conditions if they satisfy following conditions. Condition number 1, there should be two chiral centers. Second, out of 6 groups attached to two chiral centers, two groups must be same. That is 2. Out of 6 groups attached to two chiral centers, 2 groups must be same. Okay, at least 2 groups. Okay, and at least 2 groups must be different. 2 groups must be different. Okay. Now, what is Erythreo? Erythreo in E, all lines are same side. Erythreo. Or two same groups are groups are oriented, same direction, same direction, same direction. Two same groups are oriented in same direction. What is trio? Opposite. Trio. Two same groups are groups are oriented opposite direction, opposite direction. Two same groups are oriented in opposite direction. That is trio. Okay. Erythreo and trio. Erythreo and trio. Okay. E in erythreo, E all lines are same side, therefore same groups are on same side. In trio, all groups are in opposite side, therefore they are in opposite side. I'll come up with a little of example, one or two example. Let us first I'll tell you. It should be, suppose it should be two chiral centers. Therefore, a line, two chiral centers. Each cross points represent chiral center. This cross point and this cross points are chiral center. Now you have at least one group, two groups are same. Suppose A group, here also A. Now here you can be any group, X, Y, B, C, like that. Okay. Now two same groups are opposite. Here X, Y, B, A. Now this is erythreo. Because of this, erythreo. This is trio. Okay. I'll have an example, beautiful example. Look at here, CHO, glucose. You know that arabinos are the best examples. CHO, CH2OH, 1, 2, OH, HH, 2 molecules. CH2OH, CHO, OH, HH. Here we have the two chiral centers. Two chiral centers are same. Therefore, these are erythreo. This is trio. Now, another very important point. We know that this is the second last OH group on the right side. Therefore, this is G or this is L. They are arabinos, xylose. We know that. When we learn the glucose, you will learn it. Okay, arabinos, lysose, xylose, etc. Therefore, this is D-erythreo. Why D? Because second last OH group on right side. Erythreo because two OH groups are on same side. This is L because second last OH group on left side. Trio because two same groups on opposite side. Okay. That's all these two topics. I think this topic is clear for you. Thank you for watching. Any doubts? Let us discuss. Okay.